So next topic is on metallocarbonyls. So metallocarbonyls and the related compounds are mostly commonly formed by the metal in group 8 in the periodic table and less commonly by the neighboring transition elements like in group 7 and 6 and still less commonly by certain elements in group 5 of the periodic table. Then they are formed by the reacting involving carbonyl with either free metal or from metal salts. They are characterized having a CO group directly bonded to the metal atom through a carbon. So there are two different types of carbonyls are there, metal carbonyls. One is mononuclear, another one is polynuclear. Mononuclear means where one metal has been bonded to two or more ligands, but in polynuclear the name itself indicating that is a two metal ion has been bonded to various carbonyl groups. It may be a di or it may be a tri. So that is two metal carbonyls bonded to various ligands, and then three metal has been bonded to three or four ligands. So that may be mononuclear and then polynuclear. So the preparation are many for metal carbonyls. So the first one is the easiest method, that is direct combination where metal ion directly reacted with the carbonyl, and then high pressure synthesis. So in high pressure synthesis where some of the sulfur containing compounds of the metal ion when interacted with the carbonyl lead to the formation of the metal carbonyls. Then disproportionation reaction or nothing but a oxidation reduction reaction, and then some oxidation of the metal carbonyl hydrates to form metal carbonyls, and then reductive carbonation, and then photolysis and some thermolysis reaction we can perform the synthesis of metal carbonyls. And the very important one is bonding, the type of bonding in the metal carbonyls. So there are three kinds of bonding in metal carbonyls. So one may be that is CO bonding, that is a type of a bond between carbon and oxygen in carbonyl group, and one is MC bond, that is metal carbon bond, and then metal metal bond, that is in polynuclear metal carbonyls. So let us study one by one the type of bonding. So the first bonding is the bond character in CO group is much the same in the free carbonyl group, that the bond order is 3. The number of bond between a carbon and oxygen in the carbonyl groups are 3. So the same characters you can see in the carbonyl group. Then very important type of bond between a metal and then carbon, this is the type of bond. So an example, metal carbonyls, that is pentacarbonyl iron, that is 5 orbitals are used for the iron carbon sigma bond, that electrons of which are used for the CO group. So then the remaining orbital containing iron electrons, so which are used in the pi bonding. So in early we discussed such that a metal and then carbon having two different types of bond, one is sigma bond, another one is pi bond. So the overlapping of the lone pair with the carbon atom with metal, that is Nd, Ns and then Np, that these are all vacant orbitals, may be regarded as MC sigma bond, that is metal carbon sigma bond. So how that sigma bond has been formed means the movement of an electrons from ligand to metal through a carbon, that is sigma bond. Then the further source of bonding should exist in all metal carbonyls, that is there are filled non-bonding d orbital of the metal ion which overlap with the pi antibonding orbital of the CO to form MC pi bond, that is metal carbon pi bond. So here one is very important such that so you can see a movement of electrons from ligand to metal ion in coordination compounds. But here so another type of bond has been existed, that is pi bond. So how this pi bond has been obtained, that is by a non-bonding d orbital of the metal which overlap with pi bonding anti orbital, that is empty already. So it will accept a pair of electrons from the metal ion leads to the formation of an pi bond. So the formation of this additional pi bond by transfer of charge from metal can be seen. So we all know that that electron has having a negative charge. So if there is any transfer of this negative charge, so sometimes it may be a partially positive when it loses an electron. Sometimes when it will gain the electron, so it will show some negative charge. Then the drift of metal electrons into carbonyl orbital, which will tend to make CO as a whole negative, and hence it increases its basicity, which accounts the strength of sigma bond. Then the two bonds will become stable. One is sigma bond formed by the movement of an electrons from ligand to metal ion simultaneously. So the electrons which is present in the d orbital, which is not used in the bonding, then it will move to CO antibonding molecular orbital, then it will form pi bond. Then at the same time, the depth of electrons to metal in the sigma bond tend to make CO positive, thus enhanced by the acceptor of strength of the pi bond. So last one is metal-metal bonding, that in polynuclear compounds it is present either alone as in Mn or in combination with the bridged CO group. It is used to explain for the diamagnetic property of a binuclear compounds. So magnetic properties are important for the organometallic compounds to explain the diamagnetic or the paramagnetic, so it is very important. Then in generally metal-metal bonding is assumed in order to satisfy, that is 18 electron rule, to know the stability of the complexes. So we can see the formation of a bond in metal carbonyls. So one is the formation of the bond. So they are showing the arrow mark that indicates a movement of an electron take place from ligand to metal ion. So simultaneously, so the electron present in the d orbital, which is not involved in the bonding, so it will move to antibonding, that is empty antibonding molecular orbital of the CO. So it is empty already, so it will accept, so lead to the formation of a pi bond. So then from that we can having a synergetic type of effect, that indicating so give and take policy. So the ligand will donate a sigma electrons and lead to the formation of a sigma bond, and then simultaneously, so the electron present in the metal, it will move to ligand of CO, that is antibonding molecular orbital, so it will form pi bond. And also we will call it as a back bonding. Back bonding means generally we can see ligand will donate a pair of electron, then metal will accept. But here what happens, simultaneously metal also will donate a pair of electron to the ligand, that makes a back bonding, then the compound or complex will become more stable. So once again this diagram showing that arrow mark, that is movement of electrons from carbonyl to metal form sigma bond, then metal to carbonyl pi bond. So then metal nitrosyls. So metal nitrosyls also very important. So this metal nitrosyl group of metal nitrosyl compound with many transition metals, in which NO group are directly attached to the metal ion. So we can prepare in many forms. So one is some metal carbonyls interact with the nitric oxide, lead to the formation of a metal nitrosyls, and then metal nitrosyl halides can be prepared by halides of the metal when interact with the nitric oxide. Then the type of bonding. So in the first step, the complete transfer of one electron from NO to metal take place. Then that metal treated as a uni-negative and nitric oxide treated as a uni-positive containing one lone pair of electron. So then the type of bonding here, one is bent, another one is terminal group. Many metal nitrosyl halides have bent, so that is bent in form. So that is the terminal MNO group. NO can single bond to univalent group such as halogen and alkyl halides. So that is two types of structure we can see. So one is a straight chain, another one is bent in form. So then another one is very important, that is metallocene. So metallocene, I have taken one example, that is ferrocene. So ferrocene, it is a crystalline solid with a melting point of 174 degrees centigrade, so which is insoluble in water but soluble in organic solvents. Then it is thermally stable up to 500 degrees centigrade in the absence of water. Then it shows diamagnetic property, and then non-polar. Then alkali and acids do not attack on this complex, it is very stable. Then ferrocene undergo electrophilic substitution reactions such as halogenation, acetylation and alkylation by an aromatic compound. So that indicates it doesn't show the unsaturation character of the parent reactant cyclopentadienyl. So this is justified as the pi electrons of the ring are involved in the bonding with the iron atom. So that is ferrocene means a iron which is bonded to 2 cyclopentadienyl. So then preparation. So the first one is first preparation of ferrocene Grignard reagent with cyclopentadienyl magnesium bromide. Cyclopentadienyl magnesium bromide when interact with the ferric chloride lead to the formation of a ferrocene. Then direct reaction of a gas phase cyclopentadienyl with metal iron at 350 degrees centigrade. So it is one of the easiest method to carry out the preparation of an ferrocene. Then some amine bases can be used for the deprotonation through using strong bases we can get the ferrocene. Then structural property, it is very important for the ferrocene. So that we can see, so one is iron has been binded to 2 cyclopentadiene. So here also the same, the structure we can see for cyclopentadiene. So then what are the structural features? So it has a sandwich like structure in which the 2 cyclopentadiene groups are nearly eclipsed with respect to each other. So in last we have seen that a 2 cyclopentadiene, in between that a metal ion has been placed. So such type of things we can call it as a sandwich like structure. So the hydrogen atoms are slightly tilted towards the iron atom here. Then all the carbon atoms in are equidistant from iron. Therefore, the ring is assumed to have a hapticity of eta 5. So, in last class we have explained about the hapticity, that all the 5 carbon atoms has been bonded to metal ion. Then all the carbon-carbon distance are same, that is 1.389 angstroms, a value closer to benzene, that is bond order is similar to the benzene. So, the two rings are separated by a equidistance 3.285 angstroms, that is iron to carbon distance are equal, that is 2.048.